Thank you for joining today's call, and thank you for inviting me to be a speaker. Today, I will present to you a little bit of an overview of some of the key ideas from our recent book called Twin Systems, co-authored by also Professor Ioannis Brilakis, Professor Rafal Sachs, Professor Lucia Soibelman, and Professor Mark Enzer. And if you thought a PhD was difficult, well, try writing a book with 4 other professors. But we ventured on that road, and we did publish this book this year. And it's more sort of a guidance book to outline for industry professionals on how to think about digital twins. It's not a technical academic textbook. We really tried to write it so that industry can pick it up and use it as a sort of guiding framework about thinking about digital twins for the built environment. I work in the Construction Information Technology Lab, part of the Civil Engineering Department, and there's a brilliant team of researchers, postdocs, and PhDs, part of that lab, all looking into the different life cycle phases of digital twins for both roads and built environment assets. And so what exactly are twin systems, and why did we decide to go down the route of calling it a twin system rather than digital twins? Well, the analogy we like to use is something akin to the human brain. So the way we like to describe it is that a digital twin is something like a human brain. It acts in a similar way. The way that we envisage the built environment using digital twin systems is that the asset brain, or the digital twin, has the ability to both look into the past, this is called forensics, and look into the future, this is called forecasting. And the body obviously has a connection to the brain and then enacts this in the physical realm. And this is how we really describe the use of digital twins within the built environment using this analogy. And key components to being able to achieve that are our monitoring technologies and the ability to act those changes in our physical world through actuators, and monitoring capabilities with LiDAR, photogrammetry, even muon tomography. And one of the areas that we incorporated into explaining what we mean by a twin system is to go a little bit and explain the framework of our thinking. And really, the way we describe a twin system is that we often start with an intent model. This could be our BIM, this could be our drawings, CSV files, COBie spreadsheet. These all represent intention of what we want to design and build. We then hopefully construct and build that physical asset, whether it's a building, a road, or a bridge. And that is then continuously monitored through things that were mentioned earlier, through IoT devices, sensors, LiDAR, photogrammetry, real-time video footage as well. And we then create our status model. And it's the constant comparison between our intent and status model that then creates our twin system, as we like to call it. Again, this is something that many of you will have come across when people talk about digital twins, is this constant bidirectional link between the physical world and the digital world. And the way we describe it is we break it down into 2 components, which actually then becomes 4 components: the physical asset processes and the physical asset products. Our built environment is made up of both assets and processes, whether it's the physical doors, the floor slabs, windows. These are physical asset products. And then its counterpart, which then are the physical asset processes, which could relate to pouring the concrete, installing the windows. These are all processes that can be twinned. And in the digital twin world, this would be also compartmentalized into digital twins of both processes and products. A key part of our book is also to think about the life cycle of the digital twin, because we're all very familiar with the life cycle of our physical assets, starting from planning, design, to construction, to operation. And the digital twin also has its own life cycle and should not be ignored. We also have to have, key stages of planning, designing, constructing, or putting together our digital twin, and then operating that digital twin. And as you progress over the timeline of the evolvement of your digital twin, unlike the physical body, when it comes to the end of our building's life cycle, when we demolish these assets, our digital twin has the ability to live forever, the ability to provide value even beyond when that physical asset no longer exists. This is not the same with the human brain and body analogy. When we die, unfortunately, our brain dies with us. So that's as far as the analogy goes. But part of the thinking about the digital twin life cycle is an important part of our book as well. So again, twin systems, we wrote it for industry professionals. It's not a technical handbook. We wanted it to become something akin to the BIM handbook, but in a digital twin context. And that kind of thinking was brought to us by Professor Rafal Sachs. You can also find some maybe helpful, useful videos on our YouTube channel where I tried to summarize the thoughts of my co-authors as well, where we delve deeper into this concept of twin systems. And also, if you want to stay up to date with things that we're doing, you can sign up on our website. So next time we're doing a talk, you can potentially join our talk. And now I'm going to swiftly run through, I have just 2 minutes, Project Restore, an example of digital twinning for the reuse of steel. This is an EPSRC funded project that I'm leading together with University of Birmingham team. And what we're trying to do essentially is to digitally twin existing steel members, a sample selection of steel members, and then incorporate those members so that we can reuse them rather than recycle them. So the whole purpose of this research is to try and create as accurate of a digital twin of existing steel members and the typical kind of wear and tear that they will experience over its lifetime, from dents to corrosion. And we try and digitally twin these steel members. And the role of Cambridge University is to take that information and generate software. In this case, we're using generative design tools that can then incorporate both reused steel members and then new steel members. And here is a quick example of that, which is a generative design tool used for portal steel frame members, where you're incorporating both reused steel members and new steel members together into a design of an industrial building. Another last piece of work led by my brilliant PhD student, Hank Lau, is the integration of large language model-based interaction with digital twins. And Hank is leading this work. And the key part is really to be able to use large language models to actually interact and modify data from our digital twins, from model visualization, data summarization, making changes to the parameters of the design files, and summarizing historical data that may be coming through sensors. It's very simple. It's a bit like what everyone is now accustomed to, using ChatGPT, using large language models to actually summarize information. But here, the key difference is that we're also able to then modify information within our IFC files and actually visualize information from our IFC files and point cloud data as well. I do have a very quick demo, but I'm not sure that I'm already running 30 seconds over time, but I would be happy to share the final PowerPoint slides with everyone to see the full video and demo of the tool itself. Okay, with that, I'm going to end my presentation. This has been the quickest presentation I've ever done, so thank you very much.
Erika, next question for yourself is, does the book cover practical obstacles experienced by organizations and sectors, and most obviously being data sharing?
Yes, we cover some of the key challenges in the book itself, but I think our book puts forward sort of like a utopian vision. What would we like our industry to transition towards? So we talk about data sharing in the context of examples like in the music industry, how we have to transition from selling songs to selling access rights or permission rights to certain type of data. And we talk about even, how digital twins may not be all all-encompassing in one centralized digital twins, but rather we might have something akin to a network of digital twins exchanging permissions and rights to retrieve certain information. So we do talk about it, but we don't go into detailed practical obstacles. We talk about it more in a higher level of how we would envisage our industry to shift their thinking about data sharing.